Welcome back everyone to Learning with Easy. We're in statics and we're going to keep doing some frictional problems and we're going to do problem 8.57, okay? It says, the man has a weight of 200 pounds and the coefficient of static friction between his shoes and the floor is 0.5. Determine where he should position his center of gravity G at D in order to exert the maximum horizontal force on the door. What is this force? Okay, so the first thing that we need to determine in this problem is that we need to determine where this center of gravity G is going to be located according to this point D. So basically they're asking us to find what D is, and they also want us to find the force and what is this maximum force, okay? So like any other static problems, what do? Well, we do a free body diagram, right? So we're going to start with that. So we're going to do my FBD in here. Now, how do we draw this guy? Let's see. So this will be his feet up to his knee. Then we'll have onto his hip bone, and then we'll have his torso, and we will draw his hands something like this, okay? So this is the main shape of this man. Now what do we have? Well, which forces do we have? Let's start with the simple. We got this center of gravity around here. So, and this center of gravity, basically what it's telling us is that at this point, what the center of gravity G means is at that point is where we're going to locate the weight of the man. Okay, so at that point we have 200 pounds, so 200 pounds in here. We have the force. Since the guy is pulling that way, well, to the door, right? Then the door will exert an opposite and equal force to the right. So we're going to have a force that we're going to call it F for force. Then we have the normal force that the floor exerts on the man. So we got the normal force, right? And since the force wants to go on the right direction, meaning that it will try to pull my man to try to slide down in the motion of this direction, right? In this direction. Then my frictional force, it's going in this direction, trying to counter opposite down, okay? So we have our frictional force going to our left. And what do we know about frictional forces? Well, they are fun. And what I mean by fun is that they are F equals to U times N, where F is my force, U is the static friction, the coefficient of static frictions, and N is the normal force. Now, we're given that the coefficient of static friction is 0.5, therefore that force is going to be 0.5 times my normal force. We don't know this normal force, okay? So let's leave it at 0.5 N. Now we're done with the free body diagram, and what do you guys think we're going to do? Well, of course we're going to do some summatory of forces. So we're going to start with the summatory of forces in the y direction in this case, and I'll explain you guys why. So basically what I want you guys to understand is that, well, we have N here, our normal force, and we have 200 pounds. That's all we have in the y direction. Therefore, we can right away solve for one of our unknowns, okay? So we got negative 200, as I was saying, because it's going down. And then we have positive N. Now, this is all I have in the y direction. Therefore, I can solve for my normal force. So my normal force N is equal to positive 200 pounds. Okay? Next, we're going to have summatory of forces in the x direction. We're going to assume that going to the right is positive. And what do we have? Well, we have negative 0.5 N. So we got 0.5 multiplied by N. So let's just go right away and just plug in the value. Let's not forget that this is negative. Then we'll have positive F. And all this should be equal to 0. Okay? Now, we're going to solve for F. And if we solve for F, we will find out that it's 100 pounds. And this is the maximum force that we can apply into this door, okay? So we found our first answer. I'm just gonna put max in here because this is the maximum that we can get for this 200-pound man. Now the rest that we're missing is that we're missing the distance D. So over here, that I actually need to put in my free body diagram. So it's going to be more or less from here to here. This is my distance D, and we need to find it. What is this? Okay, so in order to find this force, what we can do is that we're going to apply the summatory of moments. So we're going to apply the summatory of moments at this point. So let's call point A, okay? So we're going to do the summatory of moments. We're going to assume that going counterclockwise is positive about my point A. And the reason for doing a moment is that moments are forces times distance. Therefore, if we find the distance D, which is the distance between my point A to my 200 force gravity center, like point of center, so we can find D. So let's start by doing that. So we're going to hold here, therefore we don't care about N, we don't care about 0.5 N, and all we have left is 200 pounds and my force F. So if I hold here, this 200-pound force will want to rotate me in the counterclockwise direction, so I am going to have it as positive. So we got 200 pounds multiplied by the distance. We already said that the distance was D. Then the only left force is this one, which is F. Now if I'm holding here and then I want to push my system like that, right, I will want to have a clockwise moment. So if I have a clockwise moment, I have negative my force F. Well, we found out that my force F is equal to 100 multiplied by the distance. Well, what is the distance between this line of force F and my point A? Well, it should be this line in here from A to F, right? And if we pay attention to our big drawing in here, we have 3 feet. So we have a distance of 3 feet that I actually should have, but I forgot to put my distance of 3 feet in here, okay? So we know that we put 3 feet in here and all this should be equal to 0. Now, all we do, we're going to solve for D. So if we pass all this to the other side, becomes positive. So we got 100 multiplied by 3. And we divide by the coefficient in front of D, so 200. And what is this equal to? So if we plug this into our calculator, which is, I don't think it's needed, but just in case you do, we'll get 3 divided by 2, which will be equal to 1.5 feet, okay? And this should be my answer for my distance D. Thank you guys for watching. If you guys liked the video, please push the like button, subscribe, and I'll see you guys in the next one.